do, how they work. Then I'm just going to give you a bunch of demos on how you can import them and use them in your sites, and then show you how you can create intelligent modules and walk you through the workflow of doing that. And then at the end, I'll point you to places you can go to learn more about them and get started creating your own if that's what you want to do. So that's what we're going to cover today. All right, so let's just talk at the beginning about what are intelligent modules. Intelligent modules were introduced in Composer 7.3, and what they allow you to do are control third-party devices from within Composer with native Composer user interfaces. And in 7.3, all of the intelligent modules were created by Symetrix and packaged in Composer for you to use. Well, now in Composer 8.0, you now have the ability to create your own intelligent modules. And you may not have known this in 7.3, but under the hood, all intelligent modules have a script written in Lua that defines their functionality. And now you can create those yourself. So what can you do with intelligent modules that you create? Well, first you can do the things that we've been doing for a while with intelligent modules, and that is control third-party devices. So those could be third-party Dante devices like the Alcorn McBride vPage you see here in front of you. So that allows you to control its LEDs, receive input from its buttons, and then have that information affect user interface on the intelligent module, as well as receive and send control messages, control signals through pins and through the system. And so you can do that with Dante devices. You can create your own for any Dante device that has an open UDP or TCP API that you can write a script to control. You can do the same for non-Dante devices. So here's another one that we ship, the Visionary Solutions encoder and decoders. These have no physical controls on them, but you can control their functionality via the user interface of the intelligent module, and you could now create your own intelligent module to control a similar device and monitor a similar device. But intelligent modules can do more than that, especially the ones that you create. You can use intelligent modules to communicate between sites. So if you have a large installation that has multiple sites, for whatever reason that may be, you can use an intelligent module to communicate to your Symetrix DSPs across sites. And there's other ways to do this, but now you have another tool in your arsenal to do that with intelligent modules. But one of the other really cool things are just solving complex logic problems. This here is an example of a talk request module, which allows 8 users to request to speak, and it automatically lets the first 4 through and adds the second 4 to a queue and has some override functionality. And this is something that you could have created in the past with a super module and logic modules, but it would have looked something like this. It would have been confusing, it would have been complicated, it would have been hard to update. And now you can do it with scripting and an intelligent module. And here's another example of that. And the side effect of creating logic intensive modules with an intelligent module versus logic modules themselves are that sometimes you'll get a drastic reduction in DSP. So this is an example of the request to speak 18 mic module that is a super module that ships with Composer. And the top module on the left you see is the one that ships in Composer, and it uses 66% of the Radius NX DSP. So more than half of the DSP is made up dealing with this request to speak module. And we have recreated it with an intelligent module script. And you can see the bottom one represents that. It has the exact same functionality, same user interface, and now it uses up 3%. So 66% to 3% of your DSP is a huge reduction, effectively giving you half of a processor back to do other really cool things with. So not every intelligent module is going to give you this reduction, but it is something that you very often will see with heavy logic-based designs. So those are just a few examples of the things you can do with intelligent modules, and really the sky's the limit. You have control signals, you have a user interface, and you have a script, and you can do a lot of things with those. So let's talk for a minute about creating versus using intelligent modules, because not everyone is going to be creating an intelligent module. Because creating requires some things. It requires an understanding of Lua, which is the scripting language we use. It requires some basic programming concepts. If you're going to control a external piece of hardware, it requires TCP and UDP knowledge, and you have to understand the API for the device you're trying to control, and all of that takes time as well. So not everyone is going to be creating them, but we hope and we think that everyone can take advantage of using intelligent modules, because using them is just like any other module built into Composer. Once you get it inside a Composer, you just hook it up and use it. So we think lots of people are going to be using them, and a few of you are going to be creating them, but both capabilities are there, and they're there for free without any licensing, added licensing cost on top of that. And the cool thing is that we have dedicated documentation and training for both of these paths, and I'm going to go over these at the end. But whether you're a user or a creator, we have dedicated training material and documentation for you. And today I'm going to give you an overview of using and creating them. So there are two types of intelligent modules. And I think from the examples I gave, you can kind of figure out how those split apart. You have the standalone modules, which are used to control non-Dante hardware and manipulate control signals and solve complex logic problems. And they're not associated with the Dante device. And then you have the user library intelligent modules, which are used to control and monitor a Dante device. And they're associated with a specific Dante device from your user library. And if you haven't used the user library too much already, we'll go into using that. So there's a lot of similarities between the two, but there are also some differences, and we'll highlight those as we go through today. So what's inside of an intelligent module? What makes up an intelligent module? Well, there's a lot of similarities, as I said. They both have configuration data that defines what it is and how it works. Defines what it is and its connections and things like that. They both have a control view layout defining the user interface, and then they both have a Lua script that is the heart of it that defines the functionality and hooks everything together. And then user library intelligent modules have a fourth component, which is just the association with a particular with a particular device in your user library. So let's go through these four items in a bit more detail. So configuration data, that is the name of the module. That is the number of input and output pins, control pins, and you can give them custom names and change the number of them that you need for the module. It might only need outputs, you might only need inputs, however many you need. And then the third part of the configuration data is the location of the external script file that you're going to be using with the intelligent module. And once you define that, you're ready to use it. And usually the first step is creating the user interface. And this user interface you can recreate virtually anything you see in any other module that ships with Composer. And you'll have the ability to add buttons and readouts and sliders and knobs, and you're dealing with the controls themselves as opposed to copying them from other modules. And we'll show you how that works. And then you have the Lua script. And the Lua script is, as I mentioned, that is the brains of it. It defines how everything connects and tells the module what to do with all of the information and controls that it's receiving. And you're going to create that in an external text editor and import that into Composer. And we have a really cool process surrounding that gives you a lot of really powerful features, being able to take advantage of those external editors and their capabilities. And then finally, for user library devices, you have that association with the device in your user library so that the module is connected to it. All right, so that script we talked about is written in Lua. For those who don't know, Lua is a scripting language. It's very powerful, efficient, and lightweight. And one of its key capabilities is that it's easily extended and easily extends other software. So you find it very commonly used in applications such as this that want to add user functionality to existing software. So there's other DSPs in the industry that use Lua as their scripting engine. Audio and video workstations use them as well. And video games often use Lua to allow users to add their own content, creating their own levels and things like that. So it's very commonly used in this type of application. And there's a lot of detailed information out there for it. So we're not going to teach you how to use Lua today, but there's a ton of great information, including a really detailed reference manual and quite a good book. If you enjoy reading things from cover to cover, highly recommend this book. And so there's lots of videos on YouTube to help you get started in Lua if you haven't used it before. But if you've done any scripting before, it's very likely that Lua was the scripting that you used. And as I mentioned, Lua is extended really easily. And so we've created a variety of API extensions. API stands for Application Programming Interface. And these extensions add functionality needed for intelligent module operation. So they allow you to have access to the things that the intelligent module needs you to control and monitor. So things like the device, the system, creating timers, accessing the controls on your user interface, as well as the control input and output pins, and then the UDP, TCP communication. And then if you're talking to a device that uses JSON, we have extension for that too. So this is really what you're going to be interacting with, are these Lua API extensions. Last thing to talk about before we get into the demos are how the intelligent modules are run on the hardware. So inside of your Symetrix device, DSP, whether that's a Radius NX or a Prism or a Edge, there are, to simplify things, there's two chips. There's a DSP and there's a CPU. So the DSP is what processes all the audio and all of the modules themselves. So the control modules, the audio processing, that's all happening on the DSP, while the CPU handles basically everything else: communications to and from Composer, the file system, recording to a USB thumb drive if you have a Radius NX, the front panel. So everything else the CPU is handling, scheduling. And it's important to note that the intelligent module scripts themselves actually run on the CPU, not the DSP. And so this is why, in one of the examples I showed you, that you can free up DSP resources by shifting from control modules to an intelligent module, because you're shifting processing from the DSP to the CPU. Now, like the DSP and the CPU also has limits. And in Composer, we give you a nice gauge to show you how much DSP is available. CPU doesn't work quite the same way, but we do have limits to ensure that you're not using too much CPU, that there's, with your intelligent module, that there's room for all those other things the CPU has to do. And we have a function called execution statistics that allow you to see and monitor that processing. So it's not something that most users will ever have to think about, and most creators usually won't have to think about it. But if you're working on a really intensive intelligent module with a really, really detailed and complicated script, it's something you might have to look into. And we have some best practices documentation to help you with that. All right, that's the background. Enough of me blabbing. I'm going to switch over and do a demo. I don't see any questions in yet, so I'm just going to kind of keep going ahead with the demonstration. So let me switch over to Composer. All right, so let me close this out here. So I'm in Composer right now, and let me just make sure here. Okay, whoops, sorry, switch back. So in Composer, I've just done a bit of legwork to create a site with a device. I have a Radius NX here, so that's what I'm using for this demonstration. It's important to note that intelligent modules can run on anything that supports Composer, basically. So your Edge, Radius, Prism, your Solus, NX as well. So anything there, you can run your intelligent modules on. And let's get started by talking about importing intelligent modules. So if you're just going to be using them, let me walk you through that process. All right, so I'm going to go into design view, and you see in the toolkit under intelligent modules, we have a section for create and open existing intelligent modules, as well as a user collection. And this is where you're going to interact with your standalone intelligent modules to start with. So let me start by showing you how to open an existing standalone intelligent module. Simply select the item in the toolkit and we'll drag it in. And it opens up a browser to help me navigate and find my intelligent module. And here I actually have two intelligent modules with the same name. But if you look closely, they actually have two extensions, a .mod and a .modx extension. Now, the difference is the .modx extensions represent locked intelligent modules, and the .mod are unlocked intelligent modules. Now, creators can choose to export their intelligent modules either as locked or unlocked intelligent modules. So let's go through and import both of those. We'll import the unlocked version first and show you what that looks like. So here I've imported that unlocked intelligent module, and it looks like a module. I can double click on it and see its user interface. I can interact with it, see its functionality. But because it is unlocked, I can actually edit it. So if I right click on it and choose Control Layout Edit Mode, now I can edit that user interface, and it looks pretty familiar to editing a control view. So an unlocked module lets you do that. If you're just using an intelligent module, you don't ever need to edit it. So there's no real difference between a locked and an unlocked version for users. The other thing to note is when you right click on an unlocked intelligent module, you see all of the controls for interacting with that intelligent module, including opening the external script. So let's just do that. And here in Visual Studio Code, that opened up, that's the external editor, and we'll talk more about that. You see the script. And I could edit it and change the functionality of this intelligent module. So if I'm just using them, I actually probably don't want an unlocked intelligent module. I probably just want a locked intelligent module. So I'm going to delete this one and drag in, do the exact same process, but choose the locked intelligent module. You see it has a little L at the bottom to indicate it is locked. And I can open it up and still interact with the user interface. But if I right click on it, I don't have the option here at the bottom to edit the user interface, the control view. And if I right click on the module, I don't see all of those script and intelligent module special functionality, so I can't open the script. So I don't get to see how it works, but I can still use it. I can connect it up and use it as much as I want. Notice that when you add an intelligent module in this way, I've added it to my site, but if I wanted to use it in another site, I would have to go through that same process again and import it again. Alternately, if you know you have an intelligent module you want to use regularly, you can add it to your collection. So I'm going to choose to drag in Add to Collection and I'll choose the locked one again. And now it is added to my site in the same way, but it also is added here in my user collection in the toolkit. So now I can drag in multiple ones really quickly. I can drag it into other sites, and it is always available to me. So those are the difference between opening an intelligent module and adding it to the collection. And that's how you get your standalone intelligent modules into your site. Let me delete these. And let's get a user library intelligent module in. So as I mentioned, the user library intelligent modules are associated with devices in your user library. The user library are ways to add Dante devices that you use regularly and want them available in your sites. So right now, my user library here under third-party Dante devices is empty. So I'm going to drag in add new Dante device. And I'm going to as you see here, bring that up into the middle, I have no devices in my user library. And you can add them in a variety of ways. You can manually add a device and enter in its name, its Dante product type, the number of channels it has. So that's one way of doing it. If you have the physical device, you can browse the network and select it and add it to your user library. And now I've added that microphone, Audio-Technica microphone. Or you can import a XML file if someone else provides this to you. And this is just something you can export right out of Composer, but it makes it really easy to share user library devices. So now I've added that Alcorn McBride V page to my user library. Now you click Edit, and here we have a section for Supports Intelligent Module. And I have a checkbox here noting that it does support it, so you're going to want to make sure it's checked. And then it says no module present, and that's because we haven't imported the associated intelligent module. We haven't connected the two. So I'm going to choose import and import I'll just choose the unlocked version of the intelligent module that I was provided. And now it says unlocked module present. Great. Now I can OK these, select that device, and now I've added that device to my site. And if I go to design view, you see a new section here under intelligent modules that lists the Dante device intelligent modules that are used currently in your site. So I can drag that in, and that is the intelligent module associated with that hardware. And again, I can interact with it, control it, do whatever that intelligent module allows me to do, hook it up. But because this was an unlocked module I just happened to choose, I can edit it. Again, not that you would necessarily need to do that, but I have that ability. And what's really cool is you can look at the script here. It asks me where I want to put the script. Sometimes you need to define it. And now I have the script associated with that intelligent module right here on my in my browser, in my editor. So now I can edit and view how that intelligent module works. So as I mentioned, and as you just see here again, opening that script opened it in an external piece of software. In my case, it opened it up in Visual Studio Code. Visual Studio Code is an external text editor. And whoops, let me switch back to the presentation. And so we have chosen to use an external text editor for editing your intelligent modules. And this gives you a great amount of functionality. You get the ease of use of its tight integration. We spent a lot of time making sure it's really tightly integrated and works really closely with the functionality in Composer, so it feels like it's built in, but you get lots of great capabilities of an external text editor. First of all, you get choice. You can use any text editor you want. You can use Visual Studio Code. You might already have a preference. So if you already have a preference and instead you like to use Atom, you can use that. Or if you want to use Sublime Text, you can use that. Or Notepad++. There's a bunch of them out there with their own personalities and functionality, and you can choose to use the one that best suits your need. If you don't have one, if you don't have preference already, Visual Studio Code is a great one to use. Additionally, you get powerful functionality. You get things like user snippets, multi-line select. You have advanced find and replace, and you get deep, deep customization. So you have the ability to load in plugins and extensions with a lot of these external text editors. And they also have cool things like color themes. So if you have particular needs or preferences, you can choose the color theme that you prefer to use. If you like purple, you can use purple. And these are backed by really large companies. You might have heard of one, Microsoft, right? Microsoft has a ton of engineers working on Visual Studio Code, and you get to take advantage of that. And we get to focus on areas that are best for Composer, for adding new functionality that you need as opposed to maintaining a text editor. And finally, you get to take advantage of using source control. So if you're familiar with Git and GitHub, this has a bunch of powerful features such as branching, so you can try new things with safety. You have a built-in history and backup capabilities. You can compare changes between versions and compare them. And if you have multiple developers working on your script, it has a workflow built in for that. So all of these things make working with an external editor really powerful, and we think it's a great way to go. So let me give you a demonstration of that. I'm gonna switch back to Composer. I'm actually gonna delete this V page here because we don't need that anymore. And let's create an intelligent module. Delete. I'm gonna delete it out of the site here just to keep things clean. So before we create a new intelligent module, let me really quickly show you here under Application Preferences, Intelligent Module Options. This is where you can configure which editor you want to use. So Visual Studio Code is a great one. If you don't already have a preference, use that, and you can even click the button and it takes you right to the website to install it. Or you can choose a custom one. And Notepad is always available on a machine, just in case, if you're on a client's machine and you don't have any other editor, you can quickly use Notepad to make a tweak. But we definitely recommend getting a good programming editor, and Visual Studio Code is a good one if you don't already have a preference. Cool, so let's make an intelligent module. Starts by dragging in, create a new intelligent module. I'm gonna do a standalone intelligent module because it's a little bit easier to show all the functionality from the beginning. So let's call this demo, cool name. And this intelligent module, sorry, catching up my notes here. All right, so for this intelligent module, we need, we're gonna have 2 control pin inputs and 1 control pin output. And then I'm gonna tell it where I want it to put my script. I'm gonna put it in the same folder as my site, there on my desktop, great. And I could rename those control pins, but I don't need to do that today. So hit OK, and now I've created the intelligent module with those 2 control inputs and outputs. The next step is creating the user interface. Let me drag this up. So here is a blank control view for the intelligent module. You can resize it, and you can add, as you see with the control view active, you see all of these new additions in the toolkit. So I could add in a label, a fader, knobs, push buttons, radio buttons, LEDs, meters, gauges, drop-down lists, video streams. I have a lot of functionality. Anything that you see on a built-in module, you have the built-in controls to add. For this demo, I'm going to add in a couple meters. And what these meters are going to do is they're going to represent the signal coming in on the 2 inputs, and then this bottom one is going to represent the signal on the output. So let me add a label here. I'm going to double click that and we'll call it inputs. And over here, I'm going to set the background color to be transparent, and I'm going to make the font huge just to make it extra clear. These are the inputs, and I'm going to copy and paste, and now here are my outputs. Cool. Alrighty. So next we need to hook it up. I'm going to actually hide the properties panel because I don't need that anymore today. So let's hide and make a bit of room. Slide these guys over. And I'm done editing the control view. So let me right click and turn off control view edit mode. And now let's connect it up. For this example, I'm going to connect up some control faders, 2 of them. And I'm going to connect the output to a meter. All right, and let's just view those and we'll get everything lined up so we can see everything at once. Cool. So what is this intelligent module going to do? What do we want it to do? Well, what we want to do is basically get the maximum of these 2 input faders and send it to the output. But we want to ensure it doesn't go above a certain limit or below a certain limit. And actually, this, if you happen to watch the webinar yesterday on logic modules, this is actually kind of similar to one of the modules that was created there. So showing that you can do certain things in multiple ways, but the more complicated a logic module-based approach gets, the more an intelligent module makes sense to use. So I'm going to right-click on the intelligent module and choose Open External Script and Debug Output Files. Actually, let me close that again and just do it again, because make sure that it only opens the two I need. There were a couple previously open from before that I didn't want getting confusing there. So here is the default script, and it's empty. It just says auto-generated script. And then this is the debug output file. I'm going to drag it down to the bottom so we can see them both simultaneously. Makes life nice. And the intelligent module here, let's see here. So the script is empty. I could spend a little bit of time writing it, but I'm going to actually, because it's not worth you just seeing me type, I'm going to take advantage of a cool feature in these powerful external text editors called snippets. So I'm just going to delete that and start typing the word webinar. And I had actually created a snippet automatically that when I hit enter, I don't even have to finish the word. It automatically fills with some text. And I actually have a bunch of snippets I use regularly for common things that I want to do. Like if I want to create a timer, I just go in here and I start typing timer, and boom, it just made a timer for me with all the things I need. So it's a really powerful feature, these snippets. And that's just one example of the cool things that you can do with external text editors. So I'm going to save this and import it into Composer. And nothing really happens when I import it, but Composer now has a copy of that. Now we have an option for auto import script when file changes. And this is something you're usually going to want to enable. And this means anytime I change the file, Composer is automatically going to get a new copy of that. So I don't need to click import. It just will happen automatically with that checked. So before we go online and see the functionality, let me just quickly walk through the script for you. I already kind of described what it wants to do. So how does it do it? Well, first thing it wants to do is say, anytime the control inputs change, I want to do an update. So I've called that update fader update, and that is that function in the middle. And this set of lines at the bottom are what tell Composer, anytime those inputs change, run this function using what's called an event handler. And so what does this function do? Well, it gets the values of those two inputs and stores them into two variables. And then it runs some math here to calculate that maximum value of the two and ensures it's between two limits. And I've defined those two limits here at the top. The maximum limit is 0.8, the minimum limit is 0.2. These are just arbitrary numbers to make a nice demo. And once it has that output value, it sets the output value to the one it calculated, and then it updates all those meters on my control view, showing the inputs and the output value that it's sending. So pretty straightforward, nice and logical and neat with comments. So let's go online and see that. One last thing you need to enable is this online script debugging. And this is another thing that you enable if you want to debug your site online. You can do a lot offline, but if you want to debug the script online, you want to enable that option. And again, we make you enable both the auto import and the online script debugging options because it gives you a bit of security and control. We don't want to accidentally import a script replacing what you already have there unless you intentionally tell Composer to do so. And same with online script debugging. If you already have a script on the device, we don't want to push a new one when you hit save unless you intentionally tell us to do so. You only have to enable these options once per usage of a site, and then everything will work automatically. So we got that. Let's, I think I've saved it already, but I'll save it. And then let me push the site and go online and see if everything works as it should. Cool. So now we're online, and let me raise up this input fader, and you see that the input meter is showing the exact same value as the fader I'm adjusting. And right now the output is showing the same value because this is obviously the maximum value. But if I raise that input fader above 80, now that output doesn't go above 80. So I've limited it to above 80. Similarly, if I bring that back down and cross that 20 threshold, the output won't go below 20. So it stays within those limits, sending it to the output meter. Let's try the other side. Works with fader 2. And if I raise fader 1 up and leapfrog, now it's the maximum. Now fader 2 is the maximum. Cool. So that just does what it should do. So let's do a quick change just so you can see how easy it is to change and see the results. So why don't we set the minimum limit in my script from 0.2 to 0.1 and the maximum to 0.9. Save. And now if I raise the output, it goes to 0.9. So it happened automatically imported the change to the script, sent it up to Composer, or excuse me, to my radius, and I'm seeing the results immediately. No need to re-push, just pushed it automatically. And same with the minimum value. Instead of it being 0.2, it'll now go down to 0.1. You can also use your debug output file as another example I'll show you real quickly. So let's say I wanted to check here, let's say print output value during development. Maybe I want to see here what the output value is. Again, I'll hit save. It's automatically pushed to my device. Nothing really happens until I start making an adjustment. And then here, let me raise this up now. Here in my debug output file, you see it's now updating every time the fader moves, showing me that updated output value. And I could write that to a control or do whatever. I am, in fact, writing it to a control. So this is just an example of how you can use that debug output file to print basically whatever you want. So this is great. This is just what I want my intelligent module to do. I've finished creating it. I've designed an awesome user interface. I've created a really powerful script. I'm ready to share it to the world. I'm going to right click on it, choose export user intelligent module. And here is where I get to choose, do I want to export an unlocked version or a locked version? So if you have something really private, some intellectual property in your script, or you're a manufacturer and you don't want anyone to be able to change it, you'll export a locked version and they have full functionality. They just can't edit the script or the layout of the controls. But if you want to share it with others for learning purposes or because they're going to further edit it, then you'll export a locked version and then simply choose where you want it to go, and there you go. So that's a quick overview of the process of creating, intelligent modules.
One quick question, Ben. Someone asked if they want to control a Dante device with an intelligent module, do they need to connect that Dante device to just the Dante port on the radius, or do they need to connect both the Dante port and the control port on the radius?
That's a good question. You do not need it connected to the control port other than, let me phrase this. Assuming the Dante module does its communication over its Dante port, then you would just need to have access to it in this. Let me connect that. Yes, you need to be able to have the radius send its control signals out the proper port. So if the Dante module, its communication is happening over its own dedicated control port, you need that connected to the device. If it's happening over its own Dante port, then you would need to bridge those networks so the control network can communicate to it appropriately. Hope I answered that question. It will be very device specific depending on how the device's network happens. But the control communication is going out the control port of your radius device. Let me switch back to my presentation for a few more things. So let's tell you where to go next. So we've created a variety of training courses for this. As I mentioned, there's kind of two streams, whether you want to learn how to use intelligent modules or create them. So if you are using an intelligent module, we have a simple single video and quiz training module available to you. And if you want to create them, we have a more in-depth with 6 different videos and quizzes and a final project available on the Symetrix training portal. We have a really in-depth additions to the help file. So again, there's jumping off points for both using and creating. And then from there, if you're going into creating, we have dedicated reference pages for each of the controls you can add and all their properties, each of the API extensions, the basic Lua info, and some best practices and tips and tricks, and tons of handy code snippets that you can copy and paste right into your scripts. And then we've also created a ton of examples to show you how these are used. And those are broken up into 2 parts. There's the API examples that go over each of those API extensions so you can see all of them in action and basically have an example showing you how every single API works, as well as some usage examples that combines those APIs to solve a variety of problems. You've seen a couple of those. The NOM-FIFO is the one I've showed you already, but we have a bunch of those examples available to you. And those examples live on our new Symetrix community forum. You may have already discovered this, but this is a place where you can now discuss questions with other users, both about anything related to Symetrix products, but specifically intelligent modules, and Lua scripting has a dedicated section as well. Here is the address, but even easier is to simply go into Composer and under support, choose Visit Symetrix Forum, and it takes you right there. And here you'll see we have a section for general discussion, sharing your own modules, place for manufacturers to share their own. So there's none under that yet because they've only just started working on theirs, but we'll start to see some of these getting in there soon. As well as this is the place where all of those demo files I was talking about. So we have the API demos and the user demos, or their application demos. So let me just pick one here. And you see you have a description, the script, and then you can simply download a site file. I'm just going to download it, open it. And here is this intelligent module waiting for me to read the instructions. And there's more instructions here. And then actually, let me quit and open up the script. And then here is the script that illustrates how to do, in this case, a simple queue. And in this case, the debug output file shows the output of the demonstration. So all of the intelligent module demos kind of work the same way, with instructions in yellow telling you how to get the most out of the file. Oops, wrong one. So that is intelligent modules, a brief overview of how to use it, how to create them, what do they like inside. And remember, this is a free feature with Composer 8.0. There's no extra licensing needed to use or create them. So we're really excited to see what you create with intelligent modules. With that, I'm going to jump in and see if anyone has any questions.
Here's one for you, Ben, that I have no clue about the answer to. Rod says, regarding Visual Studio Code, if I'm already using Visual Studio Community, also free, should we stick with that or switch over to Code?
There's a lot of similarities. And if I were you, I'd probably just stick with what you like and use until you run into any reason to switch. The IntelliSense should work the same. As far as I know, community supports Lua. That's kind of the big thing. Really simply here, let me open up Visual Studio Code. And when you make a new file or the file that Composer creates automatically, you tell Visual Studio Code or any text editor that it's written in Lua, and that's where you get the nice IntelliSense autofill and color coding and things like that. So if you don't get that, then you might want to switch over to Visual Studio Code. But otherwise, I would say you're probably fine sticking with what you have. But that's probably the main thing. If you don't see the color coding in IntelliSense when you open a Lua file, I would switch over to code.
Another question here. What is execution statics? I'm not even sure where they saw that.
Yeah, execution statistics. That's a great question. I mentioned it in the presentation, but I didn't demonstrate it. So why don't I demo it right here, in fact. So we're still online here with the intelligent module that we created. And if I right click on it, I didn't show all of the intelligent module options, but another one here is intelligent module execution statistics. So if I choose that, it tells me about that intelligent module. And you can see, we call it a load factor. It's using 1.3% of the load factor. And the load factor is how much processing we've allocated to intelligent modules. So it's not saying it's using 1.3% of the CPU. It's using 1.3% of the processing we've allocated for intelligent modules. So you can see it's very small amount. And in most cases, you're not going to cross 5, 10. I don't know if I've ever seen one that crossed 20%, even our most complicated intelligent module. But if you happen to create a super massive intelligent module that crosses 100% or gets close to 100%, what you're going to see is that the script will skip processing passes. And that's what the second line is. And this line will count the number of processing passes that have been skipped. And normally you want that to be 0. If it's anything other than 0, that means your script didn't run one of the times through its processing pass. Again, most times you're never going to have to do this, but these execution statistics tell you how to view that. And then the last thing to know is that you can have multiple intelligent modules in a site. So the top two are the load and skipped script passes. That's a hard one to say. Load factor and skipped script passes for this individual intelligent module. And then the bottom one is for the site as a whole, or the unit as a whole. So when you only have one intelligent module, they show the same thing. But if you have multiple intelligent modules, you'll see the bottom set of numbers are the ones you want to pay attention to. You want to make sure that all of your intelligent modules combined don't pass 100%. And this just saves you from having to do the math. It sums them all up for you. So again, there's not much you normally have to do here. Again, I don't think I've ever seen a single module that passes 20. But if you happen to have a bunch of them, they could get up to 100, and you have to pay attention to that. And it's basically the equivalent of the DSP meter here in Composer, telling you how much CPU resource you have available.
The follow-up question to that is, what is the maximum safe CPU percentage to use?
Yeah, it's 100%, because what I was saying was, this isn't percentage of CPU. This is percentage of space allocated for intelligent module operation. So we wanted to make it easy, so you could just, as long as it's less than 100, you're good to go. If it gets above 100, that means it's using more than we think is safe.
I think that's the last question that I haven't already answered in the private chat. If anybody has any additional questions here, if you have a site with multiple DSPs, do the modules run only on the archive CPU?
No, they run on the DSP itself. So they're like any other module. Yeah, actually, that's a good question. Yeah, I see why that is a question, because I said the scripts run on the CPU. No, they run on the associated CPU. So if I add another radius here and add a intelligent module there, this one is going to be running on this radius of CPU, while the other one is running on the other one. Good question.
All right. Ben, the cross-site linking with scripting, is that one of the examples we have on the forum? I don't
Yeah,
recall.
sure. Yep, it is. I could pull that down
Yeah.
real
No
quick.
need. I'll post the link. Someone's just curious how it works. I'll put a link in the chat right now for everybody. Oh, I sent that directly to Greg instead of everybody.
Yeah, it's
Correction good twice.
just for everyone's example. It's actually, I'll pull it up real quick. It's actually in the TCP socket demo. So if I open that up here, there's actually a couple. Some of these have multiple demos within them. So this one here, basically what this one does is, yeah, it's in the CPU socket demo. Basically what it's doing is pulling state from one radius into another. In this case, they're in the same site because that made life easy, but there's no reason this second radius has to be in this site. So for the purpose of making it easy to demonstrate, I put them in and download, I put them into one site, but this demonstration under the TCP socket demo is pulling state from one radius into another radius via TCP in this case. And I don't have my second radius turned on, so I can't demonstrate it right now, but that's what this one does.
All right. Any more questions? I think that's the last one. Scotty, that is cool in all capital letters. It's not the only way to skin that cat, but it's certainly a nice additional feature.
Yeah, the way it works is you're basically using the API, the control API, just like you were a third-party device, but you're using it ourselves. So just like a third party can control a radius via our API, you're doing it using scripting.
Looks like that's the last of the questions.
Cool. Well, thanks everyone for joining us. If there's more questions, you can definitely reach out to us outside of this, and appreciate the time, and we'll speak to you again soon, hopefully at another Symetrix webinar. Thanks very much.
Thanks, everybody.